Hi everyone. Next, I want to take a quick look at iterator functions, also known as X functions in DAX. What these iterator functions do is loop through a table row by row, evaluate a calculation or expression for each row, and then apply an aggregation to the results. Here's an example of what the SumX function looks like. In this case, the aggregation mode is a sum, but the same syntax applies to other X functions such as countX, average_X, rankX, and so on. The first argument of an iterator function is the table over which you want the expression to be evaluated. This can be a direct table reference, like orders, or it could be a function such as filter or all that returns a table. The second argument is the expression, in other words, the calculation that gets evaluated for each individual row. This might reference a measure like total sales, or it could be a mathematical operation, such as multiplying the values from two different columns. A very practical and hands-on example is calculating shipped quantity multiplied by unit costs. Imagine a table with a shipped quantity column and a unit cost column. When you use SumX, DAX calculates shipped quantity times unit cost for the first row, then the second row, then the third, and so on, all the way to the last row in the table. Once that's done, it takes all of those individual results and sums them together. One helpful way to think about iterator functions is to imagine that DAX is temporarily adding a calculated column to the table. This column stores the result of the expression for each row as DAX works its way through the table. Then, once it reaches the final row, it aggregates those values based on the function you're using. With SumX, it sums them. With countX, it counts them. With rankX, it assigns ranks, and so on. That's essentially how iterator functions work behind the scenes. Now let's open a Power BI report to see how iterator functions are used in a real-world scenario. In this demo, we want to analyze the volume of sold items across different product categories, which is a critical metric for inventory warehousing and restocking decisions. I've created a calculated column for single product volume using the related function, pull in data from the product cube column and the dim products table. Next, I created another calculated column called line total volume by simply multiplying the shipped quantity by the single product volume. From the report view, we can then build a visualization, such as a matrix, to display the total volume by category, using the sum of the line total volume. We could also create a measure for total volume that simply sums the line total volume column. There's nothing wrong with that approach. It returns the correct values and works perfectly fine, especially if the dataset is small and there's no noticeable impact on file size or performance. However, if our goal is to build the leanest and most efficient model possible, we would try to replicate this logic entirely with a measure. That way, we avoid storing redundant data in the table and let DAX perform the calculation dynamically using iterator functions instead. Now let's go ahead and add a new measure in our orders table. We'll call this measure total volume. Our goal is to take the values from the shipped quantity column and multiply them by the single product volume values that we pulled into the orders table earlier using the related function. Your first instinct might be to simply reference the shipped quantity column directly. But you'll notice right away that DAX won't let us do that. The same thing happens with single product volume. We can only reference measures, not raw columns. This is DAX reminding us that it doesn't know what to do with an entire column of values unless we give it additional instructions. We need to tell DAX how to aggregate those values. So instead, we might try something like the sum of shipped quantity multiplied by the sum of single product volume. That expression is valid, and DAX allows us to enter it. At first glance, it even looks like it's calculating correctly. But when we take this total volume measure and drop it into our matrix, the results are completely off, very different from what we saw when we used the sum of the line total volume column. When you look back at the formula, the issue becomes pretty clear. We're summing the single product volume column, which doesn't make sense at all. Product volume should be evaluated per row, not added up across the entire table. So what we really need is a function that can evaluate an expression row by row, iterate over the entire table, and then aggregate the results. And that's exactly where SumX comes in. Let's start typing it out and walk through the logic. The first argument of SumX is the table that contains the rows we want to iterate over. In this case, that's the orders table. The second argument is the expression we want to evaluate for each row. That expression is shipped quantity multiplied by single product volume. As soon as we start typing, DAX now allows us to reference the actual columns in the orders table. We select shipped quantity, multiply it by single product volume, and then close the parenthesis. Now when we press enter, there we go. Everything updates correctly. Our new total volume measure now matches the original sum of line total volume in the matrix. This approach makes our model more efficient by reducing redundant data. Since we no longer need the calculated column, we can go back to the data view, right-click the line total volume column, and delete it. When we return to the report, we'll see an error at first because that column was still being used in the visual. In the Fields pane, you'll notice the column now has a small warning icon. We can right-click it, remove it from the visual, and that's it. Our total volume measure using SumX is still there, still correct, and fully functional, and we've eliminated an entire column of unnecessary data from the model. To make the model even more efficient and further reduce redundant data, instead of using a calculated column created with the related function, we can access values from related tables directly inside the SumX function. In this case, the related field we need is product cube from the dim products table. For example, in the total volume measure, just like we previously pulled a related field into the orders table using a calculated column, we can now embed that relationship directly inside the SumX expression itself. When we press enter, the results stay exactly the same. Because of that, we can now delete the calculated single product volume column from the orders table. We don't need it anymore. All the information required for this calculation now lives entirely inside the SumX iterator function. At this point, we've eliminated 2 full columns of stored data without losing any functionality, simply by using a measure instead of calculated columns. This is a great example of how iterator functions help us build leaner, more efficient data models. That's SumX in action. The other X functions work in a very similar way. The main difference between them is the final aggregation step. Whether it's a sum, an average, a count, or a ranking. Hopefully, this gives you the confidence to start experimenting with iterator functions on your own. And that wraps up today's lesson on DAX iterator functions. Next up, we'll dive into DAX variables, which make complex expressions much easier to read, write, and troubleshoot. Thanks so much for watching. And don't forget to subscribe to the channel to support our work and stay up to date with future lessons.